Hello internets, sorry that it's been a little while since I posted last video. Now I'll try to change it today. I'm playing with a lot of projects and I've made some script for this video, but as I have found the best solution for making video, it's do not do any script, just go directly and shoot it. So that's what I'm doing today. I hope you will have some fun. So finally, I've made a free space on my desk which is this big, and I can show you what we will take a look today. Okay, what the hell is this? Euroset line 8. It doesn't even fit on the screen. Well, this is a PBX, or Private Branch Exchange, as you can see. It's a Euroset line 8. Which means you can connect to your telephones, your old analog telephones line, 2 external line, then 8 internal phones can be connected, and this is some power connector. So nothing to see right now, but let's take a look inside. So I wanted to turn this on, but first we have to take it apart, right? So I hope it will go easily. Yes, nothing there. And this is the interesting part. So, where to start? Let's actually try if this thing works and see if we can have some fun. So this PBX is supposed to be working. I've used it in my house many years ago, and now I want to toss it away, but before I would like to take a look inside. So this is a power cord. It's RJ45 with interestingly small notch on this side. So let's try it. Okay, the device itself doesn't have any fancy LEDs or anything which will tell us it's alive, so I had to connect 2 phones, which are here, and let's try calling from one to another. The outside lines are 0 and 1, and inside lines are numbered 11 to 18, so these 2 phones should be one with 11 and 12 number. So let's try that. We have a ringing tone. Let's try 12. And it's ringing. Okay. Oh. Hello, hello, hello. Okay, so it's working one way. Let's try another. Calling 11. Nice. So this all electronics is still working, and now let's take a look closer on this electronics. So as I said, this PBX can be connected to 2 outside lines, so you can see some similarities here and here. Then this part of the circuit is for 8 internal telephones, and this part seems like power input, some current measuring, and linear stabilizers. Now we see some bigger chips here and here. Obviously there has to be some matrix connection chip which connects analog signals together. This PBX is able to make conference calls on the inside line, and also it's possible to park a call. When you park the call, you can hear some crazy tones, so which are telling you are still connected, but you are parked. So I'm sure there is also some tone generation chip or unit. Okay, so let's start from the power connector. This board, I took the board from the case to move it freely. So this board is single side loaded, it's 2-layer, port, and there's nothing on the other side. So let's start from the power supply connector. The power goes to this block. As you can see, there's TLC 084. It's quad op amp, so there's probably some current measuring. As you can see, there are some 15 or 150R resistors. Then there are some common mode chokes and 2 linear regulators, not sure for which voltage right now, and 1 DC to DC converter, probably step down topology. Okay, this is the inductor, very interesting footprint. And let's move to another inputs for the internal telephone lines. This PBX has feature that when the power goes out, this relay will de-energize and will connect the first outside line to the first inside line directly. So here's some connection, and when this relay is turned on, it connects the first internal telephone to the internal lines. So as you can see, again, common mode choke, then there is some TVS input protection, some overcurrent protection resistors, and again the same suspect, TL084S. So this block is repeated 8 times, once for each phone line. Now let's move to the external lines. These have some more protected inputs, and I would say there's also galvanic isolation with optocouplers, some here, some here, some here. These are DC to DC isolated converters. And if I move here, you can say that this is the main processor. This processor doesn't have any flash, maybe it has only some RAM, so you need some external memory, flash memory, which is here, and here this chip could be some SRAM. Okay, so this chip is actually static RAM, is 256 kilobits, so it's 32 kilobytes of static RAM. Now, what I'm not sure about is this chip. I'm not able to find any information about it. But this chip seems it's some kind of logic between the crossbar audio analog multiplexers or switches and the main processor, which gets us to these two chips are analog crossbar switches. It can connect 8 lines on the one side and 10 lines on the other side. Not exactly this, I'm just showing it for example. One crossbar is used to microphone, and another crossbar switch is used for your speaker. And if you take a look up here, you can see two interesting chips. This one should be tone generator, DTMF or touch tone generator, and this one is also generator, but it can also decode touch tones. So the way this device works is when you take a phone, then this device listens, buttons you press, then the processor does some crunching and connects your phone line via these crossbars to another phone line. And again to TLC084 quad analog operation amplifiers. Now let's take a look how exactly this device works. So as I said, there's a relay which when this board doesn't have any power, connects outside line to the inside line. So now when I power up this device, this relay should click. And it is clicking. Okay, so let's follow the signal path, no pun intended. So these two wires from the phone goes over the relay through this common choke. This common choke actually suppresses asymmetrical and symmetrical interference, so frequencies higher than few megahertz won't go through. Then we have this TVS. This TVS is quite beefy, it can handle up to 500 voltage. And now let's move to this analog part. So this operation amplifier obviously... Ouch! This is really hot. I have to be careful. It's amplifying the microphone sound, and it's also amplifying headphone sound, which is going back to the phone. And I would like to start with the easiest thing, which is ring the phone. So the phone is ringing when you apply some 50 volts, I think, AC voltage to this line. So there has to be some electronics which applies this 50 AC voltage on the line. And if I take a look on the parts I have here, there is actually an optocoupler which have a really beefy trace going here. So I will try to manually switch on this optocoupler and see if the phone will ring. So I have some ground addition here, and I will short up this side, and it's ringing. But no more. Why is that? Did I fry the chip? Okay, so I've killed this optocouple, but no worries, we have 7 more to go. So I have to be more careful. Alright, so let's try in the second line. I hope I don't blow this away like the first one. And it's ringing. Okay, let's find out where the analog signal from the telephone goes. This is just a speaker with audio input. I don't bother to put a scope here because all the sounds we can hear, so I put it near the camera microphone, and I use this crude wire to find the audio. So I turn the phone up, and I'm not sure exactly which. Okay, we have tone. As you can hear, I found the output from this operation amplifier, which goes somewhere to this crossbar and then to this DTMF decoder chip up here. So let's move along and find this analog path from this point to the crossbars. Okay, so I have 2 phones connected here, and now I would like to find the analog path near this crossbar, and I think I found something. So if I connect here and take the phone up, yes, I can hear the tone. Okay, and the second phone is on this point. Okay, so we managed it to get to this point, but now I'm curious how this chip multiplexes to the signal to this DTMF decoder, because this can decode this decoder has only one input and we have 8 lines, so it has to be some kind of multiplexed, and so let's try that. Okay, so I have something. I take a look on this DTMF decoder, and it seems that this pin is the input. So if I put the signal here, nothing can be heard, but if I unhook this phone, you can see the signal goes to the decoder, and if I do with the same signal unhook the second telephone, yeah, the signal goes always to this chip. So this crossbar is doing switching every time to this decoder. So now let's find how it's multiplexed, because what happens if you unhook 2 phones at the same time, right? This can handle only one, so let's take a look on that. So now I try to unhook this phone, and as the first thing I try to call another phone, so I will press 11, I think. Okay, and nothing ringing because I fried that optocoupler. Yeah, but as you can hear, when I pressed the second number, it immediately went off. So again. Yes, now I can press anything and I don't hurt it from this pin. So let's try something different. Let's press, I don't know, number 8, which does nothing. And it immediately disconnects this phone from the decoder. So if I press number 1, it's waiting for the second number and then immediately disconnects. So okay, but now would I hook up both phones at the same time? Okay, I think I got it. So this is a DTMF decoder and tone generator, and this chip here is only decoder. So a while before I tried to unhook one phone and the signal always gets there, but if I unhook the second phone I can't hurt the pressed buttons from the second phone here. So this is how it works. These 2 chips are multiplexed, so at the same time only 2 phones of the total 8 can dial a tone. So I think if I put the third telephone to this PBX and I unhook all 3 of them, so one of them will not get the beeping signal and one of them will have to try luck next time. So while before I had connected the input of this decoder in here, and now I have moved to the second decoder, and take a look what happens. So when I unhook the first phone, you can hear nothing from the speaker, and when I unhook the second phone, which gets directed to this, yeah, I can hear it right now. So it's quite clever multiplexing across 2 decoders, and the third telephone has just to wait until the first 2 calling persons press their buttons and make their choice. I've taken a look closer at this Motorola processor. This version, which ends with letters A1, actually doesn't have any ROM. It has only 512 bytes of EEPROM and 256 bytes of RAM. So that's why there is program in this socket and this external memory. Also, I've noticed there are some pin headers here. They are connected to the serial line pins, but it's nothing there. And one last thing, I have found that crazy tones which are playing when you are in parked mode, when your phone is in parked, so it should be here. Come on. And One detail to this crossbar switch, actually it's made by Intersil and it's called Crosspoint switch. It has each of these chip has 96 analog switches, and these switches are arranged in a matrix, 8 rows by 12 columns. So I think it's connected that 8 rows are connected to 8 internal phones, then 12 columns are connected, like 8 of them is connected to the internal phones. Then we have 4 columns left. So one column will be for this decoder, one for that decoder, and the rest 2 columns will connect to 2 outside lines. So now it makes perfectly sense. And these crossbar switches can work from frequencies like DC to analog video, so this actually can work like a video crossbar switch. And I have also found the dial tone. As you can hear, this tone is steady. It's not the same like when you unhook the phone, right? So the delays between the tone are made also by this crossbar switch. So it enables and disables the analog path from this point, to one of the phone lines. So thank you for watching. Sorry for my bloopers. If I would like to make this video more professional, it would take me another month. So I thought, what the hell, I just make this video and move to another one. So there's a lot of electronics which I would like to show you next time. I hope it will be soon. So once again, thanks for watching, and like it, dislike it, comment, do what you want. Bye.